that's what we're using. Okay, so now what else is coming with Synergi 7? So this is a slide here just showing the annotation. I won't take time to do that, but the results, the annotation on here, and it's a little bit tricky to get this stuff, and why is it tricky? Imagine if you're here and you zoom in. So I start to zoom in. Well, these lines are going to spread apart, right? Well, this text is also going to spread apart. So when you hit the mouse wheel and zoom, we've got to move this text so that it doesn't change, so it looks the same as you're moving the mouse wheel. And that's kind of a headache. It's to make that happen smoothly without flicker, and so there's a lot of craft around this. We want to work on engineering applications and models and everything. So this is a transition. Putting on our cartographer hat, doing this mapping work, but we're going to do a good job, and then we're going to get this in place, 64-bit version 7, and move on into more engineering, and hopefully we've had a good balance of engineering and GUI and other updates. So our big priorities are on the engineering side for sure, and so we're trying to get this mapping stuff done in the meantime. The other thing with version 7 is Python. So how many use Python in here with Synergi? So, okay, maybe a quarter. So today, if you're doing Python work with Synergi, this is how it works. We've got Synergi, we have the solver interface, which is COM, and then Python talks to COM, and then you build your application with Python, which is fine. The syntax is a little bit difficult because it's Python talking to COM. And so a lot of function calls, a lot of things are just not natural. They're not Python-esque. So we set our mind to building a native Python product in Synergi. So that's in progress, and things are looking, in fact, Thursday morning we'll fire it up. We've got C++ directly to Python in your application. So we've got a native Python app. When you want to load it into Python, you just go and grab Synergi and take off from there. So much lower overhead, and the syntax is what you would expect in Python. Yep.
On that program, so we'll need to upgrade to the Python 6 program, right? The 32-bit program.
It will. Yeah, we're going 32-bit. Yeah, so our 32-bit installer should Python will work on that also. So. Oh, so you'll need to put one or the other down. So if you couldn't mix Synergi 64 and Python 32, no. Yeah. So both need to match. Yeah. That's right. Yeah, that's a good question though. It's a good question. Yeah. Yep. And some other things we're hoping to get, and we know this is a headache for everybody, us included, is auto update. We've added some tools. I won't get into all those, but there's ways that you can drag zip files to a location, and Synergi will try to auto update. And we want to do better. We want to get more mainstream with the auto update capabilities. So with the version 7 installer, and I'm not guaranteeing this, we are going to try to get auto update in place. So we'll see how it goes. It's important, especially big utilities. We want to cut down on IT time and the headaches and the overhead, and be able to update Synergi for you. Okay, so upcoming work. And I'm not going to cut into beer time, no matter what Kyle says. So we're going to finish on time here. This is a brand new feature, and I've talked to two folks about this today with Tyler, and then yesterday with Chris. The golden egg is, how can we take project work in Synergi so that stuff that you do, you can, so what ifs and things that you want to try and projects and things like that, you can capture that and combine it with a coworker so that you can say, all right, we're going to take this and then all this planning work that's been done, we can combine it together and give us our planning model for next year. we've got multi-year modeling and other things, but they don't deal with alternatives. It's just like, this is our 2023, our 2024 model. It's not dealing with all the different possibilities that could be out there. Managing that data is a nightmare, and we've been thinking about it for 26 years now, right? And systems like Esri, they have the, what's it called, Andy? The back-end data slow transaction system for version. It had a fancier name than that, though, right? Didn't it have a fancier name than that? Wasn't there like a product that did that? Yeah, that's probably it, yeah. So, and that's a huge system. You know, who knows how many, it's a slow transaction based. You need to pull in thousands, tens of thousands, 100,000 pieces of data quickly into your model. So that's just a route we just don't have the capacity to, so anyway, here we go. So this is crates. The way this works is you select an area with a query, you go to crates, and you say save it, and it creates a middling file. And so everything in that orange area right there is represented in this middling file. You could give this a name, store it somewhere, and then when you go back and load it, then it would create all this for you. And it would override duplicates, things like that. So that's what it does today. Now moving forward, we can add nuance to this. We can say, well, just give me the protective devices on that query, or the loads, or all sorts of different things that we can do. But the end result would be a middling file, and then when we load crates in, it'll just start layering them on top of each other. So talking to folks today and yesterday, one thing we might be able to do is put in like header information at the top, your name, when it was saved, what it was for, maybe some details about what's in that file. Then when you go and look at your folder and you look at these files, we could show that information on the side. So you look at a list of files, okay, this was for this project and that project. So you could have some better information about which ones to pick and choose. So this is a work in progress. It's a MVP, and we're going to hopefully get some good feedback. And I think if we work together, this can be a really useful tool. It's not going to be like SDE or something like that, but I think it's going to be useful. We're all ears if you've got a way to deal with the golden egg, you know, how we can deal with versions. We have versioning in Synergi. You may have used that. It does some good stuff, and it has some limitations. What else are we working on? Stochastic analysis. So we've got simulations, this green arrow. We're good at that. We have tons of these. My first few slides, I was talking about the blue arrow, right? We've got to run this thing. 8760 is every hour. 576 is every hour in a modeling world. So all weekdays are the same. All weekends are the same type of deal. And so you take a load flow, that, and now we've got, so the green and the blue we're doing. The red is where we're going to be doing work. So weather changes. What if it's a cloudy, what if September is cloudy? Or we have fires, or a hurricane, or all the different things that might happen with weather. Or what if we've got a new outfit that's come in and engaged customers for some sort of demand side management program. So all those sorts of things is the red arrow. We put all these together, we've got gigabytes of data from the results. And so now we've got to sift through that and give you information that's going to be useful to you. This is a big deal. This is a full circle for me. Back when I left Virginia Tech, I went to Calvert Cliffs nuclear power plant, and this was my world for a while, stability. And so we built this into Synergi now. You can use a script to set up these blocks. So, you know, integrator here, and these are ways you can pull data from the model. You can push data signals out to the model, step sizes, all this kind of stuff. And this is a run from Synergi for a StatCom, that StatCom. So we've got model load coming in here, and voltage. We're looking at the voltage compared to this step signal, and this is an error. We're running it through this integrator. That's adjusting our VARs, and it's going to a spot load. So you can see this thing had a set point of, this is in kV up there, but you can see it oscillating and bring back the horrors of controls, EE301 or something like that, right? You know, this, why are we doing this? Well, this is a turbine model here for a wind turbine. No, I'm sorry, the PV array. The folks tomorrow will be showing you a lot of stuff that, so I think this world is coming. We're not there now, but next year we might be. And it's going to be more and more of this, and so we want to get these things in place so that you can model these control systems in Synergi Electric. Here's the wind turbine. So there's no reason we can't model this thing in Synergi Electric if that's the situation you're in. Consistency now. If you run the screener and you go run a hosting capacity, sometimes the results don't look consistent. We know that. Lots of applications, different approaches, starting points, all kinds of things that can be different. So we want to try to shore up those differences and make the applications more consistent. And so that's work that we're doing. Electric vehicles. We'll talk about this on the secondary modeling. This is a car charger setup. Forecasting. This is a big deal here. These, this is from the same spot that I think Kenneth was talking about. This is a difficult one. I think we all want to know how we can forecast PV. And we've got tools, we don't have tools, we have placeholders for numbers. If you can provide those numbers, we can perhaps forecast. Difficulty is where do those numbers come from? So we do have a load forecasting application in Synergi. It's on the planning tab. And there's different ways you could set up growth and things for forecasting. We're going to do PV forecasting. There's lots of ways in Synergi now. We'll do it the DER session where you can put PV on the model, but it's just kind of bland. It's just some very crude approaches. We want to start getting customer information, econometrics, other sorts of data in here that we can use to give more sensible locations of PV. And it is going to be stochastic. It's not like we're going to say, all right, this is your forecast. No, this will be 1 out of 1,000. So we'll just run through all these things and then give some sort of summary information about where you might expect voltage issues, loading problems, those sorts of things. So it's a big deal. We're going to need help. And one of the biggest helpers is when is this becoming an issue for your utility? When are your managers, your customers asking for this kind of stuff, and when are you getting set up where you're being asked to do these sorts of studies? Because we want to be there when you need these tools. I talked about Gen Plus storage here, the battery systems, more work on that. This is the EPRI folks tomorrow will be talking about these, the 1547 IEEE standard. I think we nailed it pretty well. I think our data for this thing is good. I think we are missing some settings. There's some settings that we need to get in place, and the testing that they did was very useful. We're going to go through and self-assess on their testing, and hopefully we're better than we were in February. But we want to get more engaged with 1547. It's a massive document. There's so much in there. The ride-through is important. We know that it's important. We don't do anything with ride-through today, so we've got to fix that. Because I imagine if you're not dealing with it, anybody dealing with ride-through studies now? Voltage ride-through?
No, not yet, but it's coming.
Okay.
And it's coming.
Yeah. Yeah. So non-engineers, that's when you have so you got a big generator, maybe it's sitting over here, and some disturbance comes along, and maybe some switching happens, and maybe a switch is open. Well, that generator needs to deal with that and continue operating for maybe if that switching happens over 2 seconds, that generator needs to be there when the switching is finished. So it needs to ride through the problem. And so there's all sorts of settings dealing with this that we have to be able to model in Synergi. ADMS and DERMS, I talked about this. And so we've got down here, there's an ADMS. You can come in. We've got some very basic things that we can do with this. But this is, we're going to be putting a lot into this, both systems. We just need to understand what are the settings. We're not going to model your ADMS. There's no way. It doesn't make sense. But we need to represent your ADMS. And we need to represent your DERM system in Synergi. So that's coming along. This is a term we came up with. We worked hard on this. This is high granularity. So this is AMI data. And we've worked with quite a few clients this year to be able to run through AMI data. So this is going to be 15-minute interval data for individual customers. Run through and do simulations for these customers, or for the systems. Pulling in lots of AMI data from customers. And so we're going to continue doing this. We're going to work on ways to summarize the data and give you a better understanding of how your system is operating with real world data. Okay, so I think we're almost to the end of this thing. Contingency analysis. We've had it forever. It's a very good tool, something we work on all the time to make it better. The thing with contingency analysis is it does not deal with DER. And so that ride-through that I was talking about, coupled with contingency analysis, is going to be very important. Right, so you can see, all right, we do this switching, we lose these generators. Or if we're going to do this switching, we lose the generators, and then they come back on in our final state. There's all sorts of problems, issues that could come up with generation that we have to deal with in contingency. Fault analysis. So here's a fault at this location, and we've got contributions coming from all these generators. So we need to do more with, I can pick one location, but we need to do more of a stochastic analysis where we're looking at lots of locations and trying to root out potential problems with fault. And we also need to incorporate the protection equipment into our hosting capacity, which we're not there yet, but we will be. Reliability, same thing. If I've got folks with a whole bunch of DER in this area, I've got a bunch of rooftop solar, we need to account for that in these metrics. And so maybe we create a new metric. It'll be the Synergi Electric metric for customers that have rooftop and what their reliability looks like. Not that those customers need preferential treatment, but we need to have some idea for what things are looking like. And I think down the road, these developers are going to be looking at that also. We're going to put some PV over here. Well, what's the reliability like? We've got the hosting capacity maps. That doesn't account for reliability. So that's coming. And microgrids are in there now. This is a picture of one. You can set up a microgrid source over here, open a switch. This thing will operate in isolation. What we don't have is a controller for that. So if that microgrid source is a solar generator, maybe like that solar plant up there, it doesn't have unlimited capacity. That solar generator can only produce a megawatt. So if there's a demand of more than a megawatt down in the feeder, what happens? Well, we need to curtail customers. And from what I understand, if you run microgrids, you have contracts for customers who have signed up to say, yep, you can curtail us. And so that information we need to have in Synergi so we know what customers to curtail. We know how to deal with the generation to try to balance the gen and the load in the model. So I don't think clients are at this point today, but soon. I think lots of us are going to be dealing with this. Talk about this, and then Chris Keever is going to talk about this a bit more. It came up this morning, so I'll just leave that. SIM modeling is something we're talking about. I won't get into the details, but this is the XML, kind of a generic approach to modeling. Big deal. We hear about some clients who are implementing SIM. We continue to keep an eye on it. It doesn't seem like it's something that we should be investing in right now. There's so many more important things for us to do. But we want to keep an eye on it. If you're implementing SIM, let us know, because that's something we definitely want to know about. SIM is huge in transmission. Folks are trying to get it going in distribution. If it does start to pick up, we want to support it and And so that's something we can do. Disaggregation of loads. I imagine most of you have this issue where you've got meter demands, but you don't know how much of this is EV. So you got a whole bunch of load on here, how much is it due to electric vehicles? And the reason we want that information pulled out of the normal demand is so that we can deal with a loss of EVs when they're turned on, so we can see what the impact is and support those EVs. And so this is a big data problem, to crunch through that data and to try to pull out the EV demand. And then I think Chris Kiefer is going to get into this stuff more. I can skip over the EA automation things. Secondary networks. And if folks are here that have, anybody here that has secondary that model networks in Synergi? You do? Okay. So we're past due. We owe you all work on the network protectors. So we need to get better controllers modeled. Right now we just use reverse power flow. We need to get the actual controller curves in there and model network protectors. And there's some other requests that clients have had. So we want to jump on this. So be patient with us. We will, networks is important. We've got a lot of clients that model these. Protection modeling, all the advances in protection are, this is I think these are the IntelliTeam type of system here where these guys are talking to each other. We're just getting started in this world. And I know that if you're a utility that is dealing with these team-based devices, that we can give you information in Synergi Electric to help understand how these things operate and more insight into how your system works with these devices. So we've got the basic stuff in place now, and we're going to keep working on that. So that's what we're working on going forward, and what we've done this year. And cut into beer time a little bit. If we jog, we can make it there. But thank you very much for being our clients, and please talk to us this week. Let us know what you all need.